Mud control and handling equipment. Mud control and monitoring equipment. Correct installation and operation of this equipment is fundamental to effective primary and secondary well control. The following are the most important aspects. A. Pit volume measurement. B. Flow line measurement. C. Trip tank. Pit volume measurement. A pit volume totalizing, PVT, should be provided. A calibrated readout and audio alarm should be installed at the driller's station. The following measurement devices are required for all tanks. A float for the PVT system, to isolate other floats when the trip tank is in use. An internal calibrated ladder type scale. A remote ladder type scale, visible from the driller's station for the trip tank. A small wire line can be used to connect a float in the tank to the scale on the rig floor. Flow line measurement. A device should be provided for measurement of flow line and mud return rate. This flow show device should have a readout and alarm at the driller's station. Trip tank. Trip tanks are used to fill the hole on trips, measure mud or water into the annulus when circulation has been lost, monitor the hole when tripping, logging, or other similar type operations. There are two basic types of trip tanks, gravity feed and pump. The pump type system is better because it provides for safer and more expedient trip operation. The trip tank would be isolated from the surface mud system to prevent inadvertent loss or gain of mud from the trip tank due to valves being left open. To prevent loss of hydrostatic pressure, it is necessary to fill the hole on a regular schedule, or continuously, using a trip tank to keep the track of the fluid volume required. The metal volume of the pipe being pulled can be calculated, but mud additions necessary to replace hole seepage losses due to filtration effects can only be predicted by comparison with the mud volumes required to keep the hole properly filled on previous trips. For this reason, it is important that a record of mud volume required, versus number of stands pulled be maintained on the rig in a trip book for every trip made. Mud gas separator. The separator is installed downstream of the choke manifold to separate gas from the drilling fluid. This provides a means of safely venting the gas and returning usable liquid mud to the active system. There are two types of mud gas separators, atmospheric and pressurized. The atmospheric type separator is standard equipment on nearly all rigs and is referred to in the field as a gas buster or pourboy separator. The main advantage of this type of separator is its operational simplicity, which does not require control valves on either the gas or mud discharge lines. A pressurized mud gas separator is designed to operate with moderate back pressure, generally 50 psi or less. Pressurized separators are utilized to overcome line pressure losses when an excessive length of vent line is required to safely flare and burn the hazardous gas an extended distance from the rig. The pressurized separator is considered special rig equipment and may not be provided by the contractor. This type of separator is installed on rigs drilling in high-risk H2S areas and for drilling underbalanced in areas where high pressure, low volume gas continually feeds into the circulating fluid. Purpose of a mud gas separator. During well control operations, the main purpose of a mud gas separator is to vent the gas and save the drilling fluid. This is important not only for economic reasons, but also to minimize the risk of circulating out a gas kick without having to shut down to mix additional mud volume. In some situations, the amount of mud lost can be critical when surface volume is marginal and on-site mud supplies are limited. When a gas kick is properly shut in and circulated out, the mud gas separator should be capable of saving most of the mud. Mud gas separator design features. The atmospheric type separator operates on the gravity or hydrostatic pressure principle. The essential design features are: height and diameter of separator, internal baffle arrangement to assist in additional gas breakout, diameter and length of gas outlet, a target plate to minimize erosion where inlet mud gas mixture contacts the internal wall of the separator, which provides a method of inspecting plate wear. A U-tube arrangement properly sized to maintain a fluid head in the separator. Degassers. If a fluid's viscosity does not allow gas to break out completely, a degasser may also be used. A degasser is not designed to handle large volumes of gas, because the volume of gas actually entrained in the fluid is small. Degassers separate entrained gas from fluid using a vacuum chamber, a pressurized chamber, a centrifugal spray, or a combination. The most commonly used degassers are vacuum tanks and centrifugal pump sprayers, but many others are available. Properly maintaining degassers is not difficult. Primarily, it is a matter of correctly lubricating any pumps used in the system. In degassers that employ a float arm, joints must be kept lubricated. When a vacuum pump is used, the water knockout ahead of the compressor must be emptied daily. In general, vacuum degassers are very effective with heavy, viscous muds from which it is difficult to extract gas with a separator alone. In any degassing operation, residence time and extraction energy requirements are increased as mud viscosity and gel strength increases. In general, vacuum degassers are very effective with heavy, viscous muds from which it is difficult to extract gas with a separator alone. In any degassing operation, residence time and extraction energy requirements are increased as mud viscosity and gel strength increases. Choke manifolds. The choke manifold is an arrangement of valves, fittings, lines, and chokes which provide several flow routes to control the flow of mud, gas and oil from the annulus during a kick. Typical choke manifold for 5,000 psi working pressure service surface installation. And typical choke manifold for 10,000 psi and 15,000 psi working pressure service surface installation.